radio. Acceleration due to gravity can be calculated at any location, and then you can compare between two locations. Then we studied what was the orbital velocity. We did the same. We find the orbital velocity formula, and then to relate between two locations. Then we prove the Kepler third law, and we will use the Kepler third law for two planets to find the ratio or the proportion between the period square and r cubed. That's it. This is basically the first part. The second part is energy. Energy. With the emphasis on the chapters, I put it on energy, but this part is also important. On this part, question number 2. What is the gravitational force on a 20 kilogram satellite? What is the gravitational force, Fg, on the 20 kilogram satellite circling the Earth? The Earth radius is given approximately. The mass is given. And the period is 5 hours, which can be converted to seconds. How do you convert it to seconds in 5 hours? You multiply by 3,600. So we have the period, right? We have the period. We have the radius. We have the mass of the satellite, sorry, the mass of the Earth, and we have the mass of the satellite. We have everything there. How can we find the gravitational force? What is the formula? Look at the formula for gravitational force, the different formula for gravitational force. Gm over r squared. Mg, mv squared over r. Which of the three equations you can find, you can use? The first or the third? The first. We can use the first. Why? We have the two masses, and we have the radius. Now, we have the radius of the Earth, or the radius of the orbit, circling the Earth at a radius. So what is the gravitational force on a 20 kilogram satellite circling the Earth? Which the radius is given, is circling the radius of the Earth. You can use that, right? Also, with a period of 5 hours. So I don't know, it's circling the Earth, but that is the radius of the Earth. That is the radius of the Earth. How do we know that the period on the surface of the Earth will take 5 hours? We don't know that. It's a satellite. So what formula can we use then? So I will use this if I have, yeah, but I have to have the radius anyway. Because 2 pi r over t. So they are talking about the same radius. Yeah, so I have to be the same radius because, but they said 5 hours. Okay, I don't have the speed. 2 pi r over t. So yes, it's the radius. So the radius given, so you can use the first part. We can use also the third part, finding b. What is b? 2 pi r over t, you find b. And then, with this b, you just come here and use it here, mv squared over r. So, in any of the two ways. Yeah, there are not many questions on this part. I will bring some questions on the application of this part. Now, the Kepler third law. Let's see if we have any on the Kepler third law. Many questions. Yeah, definitely I have to bring another study guide with the first part. This is good for the second part, which is energy. but not for the first part. Yeah, there is nothing on the Kepler's third law, nothing on the... Yeah, so I have to bring another one with the first part. This is the first part, what we study here. Let me just summarize the first part. The second part will be energy, and with that will be the end of the chapter. I will cover energy in the next class. So let me just summarize this. The first part. So, understanding that Fg is equal to Gmm over R squared, which is equal to Mg, which is equal to Mv squared over R. Most of the equations are coming from here and from this. V is 2 pi R over T if it's a circular path. Then, Fg is Gmm over R squared. You can get the relationship between two gravitational force at two different locations as the inverse of the radius, this, to gravity. The gravity is equal to Gm, only depends on the central mass, and at two locations, G2 over G1 will be R1 over R2 squared, the same thing. Then we study orbital velocity. Orbital velocity is the square root of Gm over R, and that comes from pairing these two equations. Or V, as I said, is 2 pi R over T, either way. And then, for the Kepler's law can be used for one planet, which is T squared over R cubed is equal to the Kepler constant, which is the same than T squared, the Kepler constant is 4 pi squared over Gm. This is usually a constant. And for two planets, we can say that T squared over R cubed 1 will be equal to T2 squared over R2 cubed. You can see that also in this way. T1 squared over T2 squared equal R1 cubed over R2 cubed. Either way, you can use the Kepler's law for two planets. Any questions? And this is a summary of what I talked today. In the next class, I will talk about energy, and I will solve problems on energy. I will give a new study guide based on some questions on this part. You have question problems. I don't know if you have a homework on gravitation. All right, for today is enough.